Okay, so this is problem 3.5 out of Griffith's quantum mechanics textbook. And it's basically just working with the Hermitian conjugate problems. So, one way we can think about this is in terms of our inner product. If we have some operator A acting on G, a dagger is a Hermitian conjugate. So let's start off with X. Writing this as our integral. It's the integral of F complex conjugate X times G of X dx. Now, one thing that we learned when we worked with expectation values is with finding the expectation value of X, it's quite easy because it's not going to change. When we move it over like this is nothing crazy. It's just totally fine. And this is, of course, just X acting on F, that inner product. Okay, so that's pretty straightforward. And in this case, the Hermitian conjugate of X is just X. Okay, and it's unobservable, so that makes sense. Next up, we want to find it for I, the imaginary number. And if we write this out like we did before, we get this. And if we want to move this I over here, well, then that's going to change the sign since I is imaginary. So this will be negative I F star of X G of X dx. So in this particular case, the Hermitian conjugate of I is negative I. Okay. Now the next one is the derivative of X. So F d by dx of G. And this is, of course, the integral from minus infinity to positive infinity of F star of X d by dx G dx. Now we can write this a little bit better. This integral we can find by integrating by parts. We'll let U be F star and du be the F star dx. And then on the other hand, we'll let dv be dg by dx. And integrating that, of course, you just get your g of x. So integration by parts, remember, is uv minus the integral of v du. So this is then just F star G evaluated from negative infinity to positive infinity minus the integral from minus infinity to positive infinity of V, so G, du. So d F star dx. Now this is going to be in Hilbert space, so these have to go to 0 at plus and minus infinity. You can think of like our wave function, it has to be normalizable. And if that's the case, then those need to go to 0. So this, if you look at this integral, it's equal to minus the integral from minus infinity to positive infinity So evidently, we just have this negative sign that comes along if we move this over here, because this is essentially just d by dx of f g. So then our Hermitian conjugate for the derivative is just minus d by dx. Okay? So now, moving on to part B, we want to prove some stuff here. The first is that Q r hat, their Hermitian conjugate is r hat, or I'm sorry, r dagger, Q dagger. Okay. Well, again, we're going to use this same idea where if A is some operator, its Hermitian conjugate is expressed like this. Okay, but instead of A, we're going to use Q and R. And of course, we can write this like this. Oops, did not mean to do that. Okay, these are, I don't always put the hats on the operators. And then we can move this Q over, so we get Q dagger F. Q dagger F. And then we have R acting on G. And now in the next step, we can move the R over. And then we have R dagger, Q dagger, FG. So then we can say that this Hermitian conjugate is just R dagger, Q dagger, where R dagger flips. And you might have seen something like this in linear where you try to find the transpose. Similar idea. This is just a way to work with it in terms of the inner product. The next one we want to show is Q plus R equals Q dagger plus R dagger. Let me make sure that one is correct. Scroll back up. Yes, okay. So, again, we have F Q hat plus R hat, and then we have our G, and then we can break this into a couple different ones here. So I'm breaking this up into two expectation values, and then of course this will get you Q dagger. That's not where I wanted that. Q dagger on F G plus R dagger on F G. So Q plus R is just going to be Q dagger plus R dagger. And then the last one to show is CQ equals C complex conjugate Q dagger. So again, we have F, some constant Q, some constant C, and then Q on G. So this is just going to be C star Q dagger F on G. So this Hermitian conjugate is just as such. I think I should have put this down here as well. Okay, so that proves those parts. And the next part is to find the Hermitian conjugate for the raising operator for our harmonic oscillator. But just to remind you, is this stuff. This is actually quite easy for two reasons. Number one, this is an observable, so that's we know to be true. And same thing with X, which we even showed. And we showed that this is just the negative of that. So the only thing that happens is that I changes signs. So this now just becomes positive I. And that's all that there was to this. So hopefully that helped, and if it did, please like and subscribe, and I'll try to post more. Thank you.